Hello, Ibsl2. Today is all about graphing trig functions. So if you notice, I'm starting to set up my notes for sine theta. We're also going to do cosine theta and tangent theta. So circular functions might be a good, or graphing trig functions might be a good title for you today. We are going to start by looking back at our unit circle and what happens as the point P travels around the circle. So if you notice, our distance in radians, I guess, is along our x-axis right over here. And we are about to draw this as our x-axis as well. What we are going to graph is actually the sine value as this point travels around. So if we stop at, let's say, pi over 2, which is what this is tracing right now, is just where we're going. So the radian that we're at right now is pi over 2, and what we would graph as the y-coordinate is what the sine value is at pi over 2. So if I animate P, and I want to show the sine graph here, that means that as I pull P around the circle, it is going to start to graph my sine function. So at pi over 2, my sine value at pi over 2 is 1. So there's my sine value. My sine value with radian of 0 is 0. And then if I continue to drag my point around, sine at pi, you guys know this already, is 0 again. Sine value at 3 pi over 2 is negative 1. There it is, right down there. And as I pull it back up to 2 pi, I'm back up to 0. So there is my sine curve. Now think about this very similarly for cosine, right? If you guys have a cosine graph, remember you're looking at the x value. So at 0, my cosine value is 1, which is why if I start to graph that, if I start to take this around, there we go, and pull, it started up here at 1. So my cosine value at 0, my x value is 0 because that's my radian measure. My cosine value is 1. And what happens to that x distance as I pull the point P up to pi over 2, right? My x value disappeared and went to 0. So now at pi over 2, my cosine value is 0. And this is going to continue as I pull it all the way around the circle. And you guys can pause this at any point if you want to look back at why this is happening. But very similar, right? And then when I do my tangent graph, I'm taking my sine divided by my cosine. And we'll do that together in just a moment. So let me pull you back over here to our notes. All right, we're going to look at sine first. And my sine value, got to make sure I have my pen ready to go. There we go. Okay. So my sine value here, I'm going to make a little XY chart over on the side. And what I'm going to say is that my x value is actually going to be my radians. And my y value is actually going to be the sine value. Okay? So what you guys were noticing in that picture was if I had a radian of 0, you know my sine value is also 0. So when I come over here to start to graph, we have to make sure, of course, that you guys always set up at least, you always want to have at least your pi, 2 pi, and then pi over 2, and 3 pi over 2. You always want to at least have those marked on your graph, on your x-axis. And then a lot of times you'll also have space for the negative values as well. In this graph, we don't have any. And then we also want to make sure that we have at least 1 and negative 1, depending on what your graph is. Right now, we're just doing the basic sine, cosine, tangent graphs. So I'll go ahead and grab blue so you guys can see me in blue. All right, and there's my 0, 0. That's where sine is starting, okay? And this is going to continue, all right? If my radian measure is pi over 2, you guys just saw that in the picture. If my radian measure is pi over 2, sine is now 1. So I'm right up here. At pi, sine is 0. At 3 pi over 2, sine is negative 1. And at 2 pi, sine is 0. Remember that we always graph these with a nice curve as much as I can with this smartboard marker here. You guys can probably do a much better job on your actual notes. Okay, and right now we're only looking for where x is basically between 0 and 2 pi. So that's my limitation here. I can only go from 0 to 2 pi with my picture. If I went further, that's fine, and I would have to put arrows on the end or continue to wherever my interval is. Also notice that sign is about to repeat at 2 pi. This is called your period, right? The period of 2 pi of a sine graph is always 2 pi. And you guys are going to do an activity in just a moment to work with how that period changes. So this is just sine of theta or sine of x, whatever you want to call your variable. But the regular period is 2 pi. It takes 2 pi radians for the sine graph to come back to where it started and then to start over again. Let's take a look at your cosine graph. Okay, we've already talked about cosine graph a little bit, and we've taken a look at how that point travels around. So I'm going to do the same thing. I'm going to set up my radian measures, and this time my cosine values. Okay, now this time, again, make sure that we have our, go ahead and take a moment to label your x-axis. We always have to make sure that you at least have your pi, 2 pi, and then please at least put pi over 2, if not pi over 4. And honestly, depending on what your graph is, as we graph some different ones besides just the basic sine, cosine, tangent, you'll have to change these marks anyway. And 3 pi over 2. Okay, make sure we also label -1 and +1. Okay, I'm going to go ahead and switch back to my blue. Okay, and again, we talked about this a little bit already in that earlier picture that I showed you, but if your radian measure is 0, well, for cosine, at 0, this whole distance here, right, that's actually +1, which is why our cosine graph starts at +1. As that point travels around, the next check-in point is at pi over 2, which my x value has changed to 0 at pi over 2. And at pi, I am now in the negative world for x's here. So to the left is -x. Excuse me, -1. And then at 3 pi over 2, we're back at 0. And at 2 pi, we're back up at 1. Again, this is basically your sine graph. And it's shifted now, right? We have shifted by pi over 2. So here I'm going to try to connect nice and smooth all the way until it begins to look like it's about to repeat again. And we're going to repeat again every 2 pi units. So our period for cosine is also 2 pi. And we're also only looking at it from 0 to 2 pi. Now I called this graph cosine theta, so really I should call it 0 is less than or equal to theta, which is less than or equal to 2 pi. And that's my only interval that I have for it. Okay? Let's take a look at our cosine graph. Again, go ahead and take a moment, set up your x-axis with the minimum requirements. There's our 0. We can do our pi over 2, our pi, 3 pi over 2, and 2 pi. And also make sure that you have your -1 and your +1. Okay? Let's try to make that look a little better. There we go. All right. Okay, so now we're back to our tangent graph. Remember what your sine and your cosine values were. So here, let's take a look at, I'm going to write down what my radian is. My radian measure is. And then I'm also going to write down what my sine value is. And I'm also going to write down my cosine value. And then we're going to write down your tangent value. Again, always be thinking about why these graphs look the way they do. Do not just accept it on Miss Wonder told us that they're supposed to look like this, or Miss Pacifico said they're supposed to look like this. Always go back and make sure that they actually make sense to you so that you can remember them. And if you don't remember them, you have a way of setting it back up so that you're not constantly kind of relying on your memory. You can actually know enough to set them up on your own. So we are going to start again with a radian measure of 0. Remember that sine at 0 is what? Right? Let's go ahead and put 0 in there. Cosine value at 0 is 1. Tangent is defined as, I'm going to put this up here, tangent theta is sine divided by cosine. We are going to talk about these a little bit more next class because we start talking about our identities. But we're going to go ahead and graph this for now. Sine divided by cosine. So if I take sine of 0 divided by cosine, which is 1, well, 0 divided by 1 makes 0. So at radian measure of 0, my tangent value is 0. So there I am. I actually have a point there. Okay. Let's say I'm going to leave a little space here because we're going to come back. But I'm going to go ahead and hop down to pi over 2. Okay? Pi over 2, sine at pi over 2 is 1. Cosine at pi over 2 is 0. If I take sine divided by cosine, 1 divided by 0, that is an undefined value. Anything divided by 0, any number divided by 0, you get an undefined value. Well, what happens in our graph at pi over 2? If it's undefined, that means we have no value at pi over 2, which means we have an asymptote. So I'm going to go ahead and put that there. Now remember, if that's happening whenever sine has a value and cosine does not have a value, think of other places around that unit circle where cosine has a value of 0, right? Cosine has a value at 0 at pi over 2 and at 3 pi over 2. And that's going to happen at every pi over 2 units. So every time that we add pi over 2, we're going to have another 0 value for cosine. That means I'm going to have a value for sine, I'm going to have a value of 0 for cosine, and I divide those and I'm going to get undefined. So that means that every pi over 2 interval, we are going to have this asymptote approach. Okay, we're going to have it come in. So now every pi over 2 units, I have an asymptote. Great, so now that's there. Well, let's think about this as well. When is sine 0? Sine is 0 at 0 and at pi, because again my y value is 0 here. So it's going to be 0 again at 2 pi and 3 pi and 4 pi. So every pi units, we are going to have this sine value of 0, which means if this is 0 and I divide it by whatever the cosine value is, 1 or negative 1, I'm going to get a tangent value of 0. So that means that every pi units, I'm going to have my sine value, and my sine value 0, so it makes my tangent value 0. Okay? So when you're moving by pi over 2, it's a whole pi units. You're just starting at pi over 2 and then going to 3 pi over 2 and so forth and so on. So every time that you're adding pi, you're just starting from a different place. I'm adding pi either from pi over 2 and getting the asymptote, or I'm adding pi from 0 or pi and I'm getting the 0 value for tangent. So that's why that 0 is going to repeat forever and ever and ever, as long as this graph continues. We're only looking at the window from 0 to 2 pi. Well, so what else happens beside these points at every pi units and these asymptotes for every pi unit starting at pi over 2? Let's take a look at what happens at pi over 4. Okay? At pi over 4, what is our sine value? Well, if we remember, root 2 over 2 or 1 over root 2, however you would like to write it. Try to write it as neatly as I can in here. Okay? Cosine is the same. It is the same value at pi over 4 as sine is. So root 2 over 2, root 2 over 2. I divide those by each other, sine divided by cosine, I get 1. So at pi over 4, midway between 0 and pi over 2, I have a y value of 1. Okay. Again, since sine and cosine, right, they are going to be very similar, except when you look at when is tangent negative, right? Tangent is going to be negative the next time that we have a 45-degree reference angle in the second quadrant. So when I move from 45 degrees, here's 90, 135 degrees. or pi over 4, 2 pi over 4, 3 pi over 4.